Hello, data explorers. We're here today to discuss distributions and specifically how to create a normal distribution in Qlik. My name is Igor Alcantar, and before we begin, please make sure you visit the Data Voyager blog. You can bookmark it so you will see on the other side, this right here, you'll see our QR code. Make sure also, if you're watching this on YouTube, to like this video, share with your friends, and subscribe to our channel. That is very important to get this message spread to most people. So let's get started. Before showing distributions in Qlik, let me give you a very brief introduction of distributions, specifically normal distributions. So if you Google it, distributions, probably the first result you'll see is normal distribution. I'm not going to read this to you. Don't worry about formula or anything. I want to focus on this graph right here, which I will expand it. So this is a classic picture of a normal distribution. First of all, what is a distribution? In statistics, distribution is a curve that shows probability of values happening, values of a certain variable in a certain sample or population. So let's say we're analyzing the health metrics of a certain population. It could be heart rate, for example. It could be the height. It could be the sales in a given company. Those are variables. It could be either a sample or the entire population of data. So the central limit theorem says that if you have a sample that is large enough, your sample data will look like the population, and as not considering this external factor will push this number up or down. Let's say it naturally happens. Then if you get a sample that is, or a population that is large enough, the curve of probability will look just like this. The highest peak of the curve, it is also the average, is the most common. So it means that most of values will occur on the peak of the curve. So let's say, for example, we have a normal distributed data, let's say height of a population, and the average is 50 centimeters. Let's say it's a small mammal. So if it is normal distributed, that number on the top is 50. So it means that most of the values will occur close to that area. And that's a curve of probability. So what's the probability on that species finding an animal that is larger than 50, larger than 60, larger than 70? Well, that is around 50 or close to 50 is pretty high, because that's most of the animals. And because this is a probability curve, it means that if we calculate the area of all probabilities, we know this, the sum of all probabilities, if I get every single outcome on an event and I sum them all, the result is 100% or 1. Let's say I have a dice with 6 sides. The probability of the number being between 1 and 6 is 100%, because those are all the probabilities, all the possibilities. So if you calculate the area under the curve for certain amounts, let's say this is 1 standard deviation. What is the probability of a certain value in a normal distributed curve to be between 1 standard deviation and 2 standard deviations? So that's the mean, and that's the this is the standard deviation, 2 standard deviation, 3 standard deviation. So what is the probability? You just calculate the area, knowing the total area is 1, so that is 0.136 or 13.6%, and so on. Okay, so enough of the normal distribution. That's the behavior of normal distribution, and is very helpful because you can apply those rules to your data, and then you can understand how rare a certain occurrence is, or if it is a certain number is an outlier, or if something you might expect to repeat in the future. Now, Qlik has a lot of functions for distribution. We can see in the Qlik help We have a few options here. And this video, I'll discuss normal distribution. And basically, for a normal distribution, I need what value I want to distribute. It is, what is it? What is the mean or average deviation? All right. If you want to do cumulative or not, there will be a topic for another video. So let's focus on these three first parameters. So that's our data. So we have basically an application with sales data. Okay. And I've even started a sheet where I basically have how many orders I have, and I have a box plot showing, and I using this box plot to work as kind of a detail KPI, because if I hover, I have a summary of the statistics. So then I see that the median is 983. Well, what is the average? Well, we can calculate that as well. The first quartile is $595. This is sales. So it means that 25% of the sales are less than that number. And then so on, the third quartile, and then I have the interquartile range times 1.5. That's what defines the full size of the box plot. And then everything that is over that size, we consider outlier represented by the dots. Very simple, classic box plot. Okay, so I can tell, because of the number of outliers, this is not normal distribution. But we're going to use a normal distribution function anyway, just to draw the curve of this application. So it is actually very simple. So I'll add a sheet, and I'll use a line chart. That's the most basic, or one of the most basic chart types. So no fancy extension needed. So you just drag the line chart. Let's make this big enough. But here's a trick. I want to show the probability of a numeric value to occur, which is line sales amount. That's my sales field. So in the data properties of my line chart, I want to add line sales amount as a dimension. So I will do line sales amount, which is my sales column, as a dimension. And then the measure is the probability of each one of those values to occur. That's why we need the norm dist function. So let's create a measure. Let me expand this so it's easier to read it. Let me zoom in a couple times, maybe 3. And let me type the function norm dist. All right. So the norm dist, again, I need 3 parameters. What is the value that I want to display? What is the average of that value? We can calculate the average, or I can input the average. Let's say, well, I can input a theoretical value. So my field that I want to analyze is line sales amount. So I can type line sales amount. Very good. What is the average? Let's say it's the total average of line sales amount. That's what the average I want to consider. We could use that analysis to focus on a specific category of products, etc. But let's make it as simple. So it's going to be the average total of line sales amount. Pretty good. And the standard deviation, it's also the same logic. We use the stdev function, which is a standard deviation function in Qlik, and the total standard deviation of the line sales amount. So what is the standard deviation? Basically, it's a level of variance. How spread is my data? All right. And then it is cumulative or not. It's not cumulative. I don't want to draw a line that shows the probability of something happening and accumulate that value. I want the point. I want the probability of each one specific value. So I'm going to do this as a 0. It's not a cumulative. All right. If you want to play, you can replace this 0 and 1, and you can play with that. Right. Let's label properly. I will label this as, let's say, probability of x, px. There we go. It doesn't Doesn't help me much. Well, we need to do a little settings, and we can zoom out back to what we had before. It shows a line, but it's just because we're showing just a piece of it, have a huge curve. So let's play with this. Let's go to appearance. Let's go to the x-axis. Let's turn off the auto, and let's make sure this is checked. So I want the continuous scale. All right, that's my distribution. Pretty good. Now, what is the average? I know the median. What is the average of that value? We can add a reference line. So if you go to add-ons, reference line, but in that case, I want to add a reference line in the X in here. So it's dimension reference line. Let me add that. So my formula will be average total of line sales amount. There we go. And we can call that, we can make this, I don't know, another color, maybe a little reddish, orange. Make this dash, and I'll label this, we can call it mean. That's how statisticians like to call it. That's the mean. All right. Interesting. That's the mean, but there's so many outliers. You see that? That does not look like a normal distribution curve. All right. So, but that's because that's the nature of our data. If you look at it, the mean is less than 1,000, and the median, I'm sorry, and the mean is over 1,000. So not too far from a normal distribution, but not normal distribution, because we have these outliers. We can tell by looking at this very large amount sales, but those are the exceptions. They happen like once in a lifetime. So they kind of making this distortion in our data. Hard to predict. We cannot apply these rows we see in here. That's a normal distribution. That's the reality of our data. In a later video, we can explore what we do with distributions like this to treat or simulate that is a normal distribution, and then use the property of a normal distribution. I hope you like this video. Again, don't forget to subscribe to our channel and share this video to as many people as you can. Thank you. See you next time.